the next thing when talking about functions that we need to be able to do is we need to determine whether one of our representations actually represents a function. So some key points from the definition is that if I am given the domain or the set A, every number in that set A has to be used for something to be a function. And the other key point is that those items in set A have to map to unique elements in the set B. So first thing I want to go is a couple table of values, and we're going to check to see if it's a function. Okay, so I have the numbers 2, 3, 4, 5, and 4 in my set A, and they map to different numbers in this set B, so let's see if it's a function. 2 maps to 11, 3 to 10, 4 to 8, 5 to 5, and 4 to 1. This is not a function because I have the number 4 in the input set called the domain that maps to two different numbers. Number 4 maps to the 8 and a number 4 maps to the 1. Similarly, in the second demonstration of tables of values, I have the number -1. It's listed twice. One time it maps to the number 4. The second time it maps to the number 5. So it fails the uniqueness test of a function. So this relationship is not a function. Sometimes you may see them listed in set notations, where set A represents my inputs to the function or the domain. In this case, it's the numbers 0, 1, 2, and 3. And set B represents the range, 1, 2, 3, 4, and 5. So the checks that I want to do to make sure that this is a function is, for my 3 example sets of ordered pairs, I want to see if every value of the domain is listed. So I need to have 0, 1, 2, and 3. So I have a 0, I have a 1, I have a 2. This is not a function. And the reason why it is not a function is 3 is not used. Okay, and again, the 3 that I'm talking about is the 3 from the domain. Let's check the second group. Do I have 0, 1, 2, and 3? I've got 0, I've got 1, I've got 2, and I've got 3. So it passes the first test. The second test is to see if any of the numbers in the domain maps to more than one number in the range. And we can see that 0 maps to the number 1, and 0 also maps to the number 2. So this is not a function. And the reason why this one is not a function is that 0 does not map into unique values. And let's check the last set. Again, the first thing I want to do is, if I'm giving a set, is check to make sure all of my domain is used. In this case, 0, 1, 2, and 3 are all used. And they're all used only once. So this one is a function. Because if they're used only once, it's impossible for them to map to two different numbers. One thing I want to point out is that every number in the range does not have to be used. In this case, 2, 3, 4, and 4 are used. Okay? But they don't have to be used. And the other thing is that two different numbers can map to the same y value. For example, here, 2 maps to 4 and 3 maps to 4. And that's okay because each input maps to a unique output. I don't need each output to come from a unique input. The last way I want to be able to check for functions is if I'm given an equation, I want to determine whether or not these two variable equations represent functions. Well, the way you can tell if they represent functions is just see if you can get more than one answer from the mathematical operations you're doing. If I start with the number x and multiply it by 2, I can only get one answer. And then if I add 5 to it, I can only get one answer still. So basically, a linear function, or every linear equation, is a function. Let's start here. If I add 2 to a number, there's only one possible answer I can get from adding 2 to a number. And if I take 3 divided by that number, again, there's only one possible answer for it. So this is a function. Over here, I've got y equals 2/3 times the quantity of x minus 1 squared. If I take a number and subtract 1, I'm only going to get a single number. Take a number and square it. Again, it's only a single number. And multiplying a number by another number, again, gives me only a single number. So that one is a function. Okay, so let's pick a number here for this one. Y squared equals x. Let's see if it's a function. Well, let's put a number in for x, for example, 4. And I want to solve for y to see if I get a unique value. Well, to solve for y, you're going to take the square roots of both sides. And in this case, you get y equals plus or minus 4, which is two different numbers because, actually, plus or minus 2. Two different numbers because negative 2 is a number that I can put in y. Basically, if I have a 4 for x, it can come from putting a negative 2 in for y or a positive 2 in for y. So this one is not a function. Okay. Basically, any time that you have the y variable or your output or your domain your range variable to a even power, everything in there in even power, it's probably not going to be a function. Same thing here. What if I want to figure out what numbers I have to put in for y to give me the number 4? Well, here I have a negative 4 can be here, and also a positive 4 can be here. Well, that x is my input, so I can have two separate values here, so this one again is not a function. The two that you have to be very careful about to determine whether or not they're a function, as of right now, is when you see the x to the first power and y to an even power, and x to the first power and all of your y's are inside absolute value symbols.